This video covers the third and last page of notes for the topic of Introduction of Polynomials. Let's continue with the information regarding x-intercepts of the polynomial functions. We can determine the possible number of x-intercepts for polynomials starting with the linear function. The linear function is a polynomial function in which the degree of the polynomial is 1. We are used to seeing the linear function written in the form of f of x is equal to mx plus b. As a polynomial, we can write it as p of x is equal to a sub 1 x plus a sub 0. And we find that our slope m is equal to a1 and b, our y-intercept, is equal to a sub 0. And the number of x-intercepts is 1. This means that any and every line will cross the x-axis only once, as shown here. For the quadratic function, we would write it as f of x is equal to ax squared plus bx plus c. But it is also a polynomial function in which the degree of the polynomial is 2. We can write the quadratic function as p of x is equal to a sub 2 x squared plus a sub 1 x plus a sub 0, where a would equal to a sub 2, and b is equal to a sub 1, and c is equal to a sub 0. The number of x-intercepts can either be 0, 1, or 2, as we saw in the last unit. The number of x-intercepts depends on the discriminant of the quadratic equation. So we can have 3 possible ways a parabola can cross or touch the x-axis. Notice the sketches here along with their discriminant values. The parabola that does not touch or cross the x-axis occurs when the discriminant is negative, as this will lead to an imaginary solution when solving the quadratic equation. The parabola can touch the x-axis when the discriminant is equal to 0. This happens when we solve the quadratic equation and get only one distinct solution. Finally, the parabola can cross the x-axis twice, but not more than twice as noted in the last graph. This happens when the discriminant is some positive value. This means we will get 2 distinct solutions when we solve the quadratic equation. For the cubic function, we would write the polynomial function as p of x is equal to a sub 3 x cubed plus a sub 2 x squared plus a sub 1 x plus a sub 0. The polynomial is of degree 3. The number of x-intercepts for a cubic can either be 1, 2, or 3. This is what cubic functions look like to illustrate the number of x-intercepts. For the quartic, or the 4th degree polynomial function, is written as p of x is equal to a sub 4 x to the 4th, plus a sub 3 x to the 3rd, plus a sub 2 x squared, plus a sub 1 times x, plus a sub 0. The polynomial is of degree 4. The number of x-intercepts for a quartic can either be 0, 1, 2, 3, or 4. Here are what quartic functions can look like to illustrate the number of x-intercepts. Hopefully you noticed a pattern here with the degree of polynomial and the possible number of x-intercepts. If we look at the linear and the cubic functions, Both are odd-degreed polynomials, and they will always have at least one x-intercept, and at most they can have the degreed number of x-intercepts. So we can conclude that odd polynomials can have 1, 2, 3, and so on, all the way up to n number of x-intercepts. If we look at the quadratic and the quartic functions, both are even-degreed polynomials, and they can never touch or cross the x-axis, and at most they can have the degreed number of x-intercepts. So we can conclude that even polynomials can have 0, 1, 2, 3, and so on, all the way up to n number of x-intercepts. Finally, let's talk about the domain and range of the polynomials based on their degrees. For all odd-degreed polynomials, their domain and range are that of the linear or cubic, which is from -infinity to +infinity. For all even-degreed polynomials, their domain and range are that of the quadratic. The domain is from -infinity to +infinity, while the range will depend on the graph and the equation. This concludes this video.